independent variable. In the fourth example, 2 dx dt plus dy dt plus 2x plus y equal to 10. Here, t is independent variable, and a variable is called dependent if the derivative of that variable occurs. Here, first example, y is the dependent variable. In the second example, y is the dependent variable. And in the fourth example, x and y are a dependent variable and t is independent variable. Okay, clear? Now, I want to say differential equations are divided into two classes. Ordinary differential equation, a differential equation is two branches. One is ordinary differential equation. Another is partial differential equation. One is ordinary differential equation, one is partial differential equation. Now we come to know what is ordinary differential equation. Actually, a differential equation involving ordinary derivatives of one or more dependent variables with respect to a single independent variable is called ordinary differential equation. A differential equation, there may have one or more dependent variable, but there will be only one independent variable. Such equation is called ordinary differential equation. So, in the first example, dy dx equal to sin x, it is an example of ordinary differential equation. Here, y is only dependent variable and x is independent variable. And in the fourth example, 2 dx dt plus dy dt plus 2x plus y equal to 10t, here x and y are two dependent variables and t is independent variable. And all the first four examples are of ordinary differential equation. And in the fifth or sixth example, these examples are examples of differential equation. So, a differential equation involving partial derivative of one or more dependent variables with respect to more than one is called partial differential equation. So, in the fifth example, here z is dependent variable and x and y of a partial differential equation. Here also u is dependent variable and x, y and z are three independent variables. Today we mainly discuss on ordinary differential equation. Okay. First, in ordinary differential equation, we have to know two fundamental terms, order and degree. অর্থাৎ order আর degree কাকে বলে? Actually, the order of a differential equation is the order of the highest derivative appeared in it. The degree of differential equation is the degree or power of the highest order derivative when the equation is freed from radicals and fractions in respect to the derivatives. So we now write another two examples of differential equation as d3y dx3 1 plus into 1 plus dy dx whole square equal to 3 dy dx d2y dx2 whole square. In this example, the highest order derivative is 3. So, order is 3. Or degree, the degree of highest derivative, degree or power of highest derivative is here only 1. So, here degree is 1. In another example, 1 plus dy dx whole square whole to the power 2/3 equals to d2y dx2. Here also order is 2, but degree is 3, because first we have to freed the equation from radicals or fractions. So it will be 1 plus dy dx whole square whole to the power 2 equal to d2y dx2 whole to the power 3. So order is 3 and degree is also order is 2 and degree is also 3. In this case, we have to remember a important thing, that the degree of every equation, degree of every differential equation may not be defined. This is an important fact. First I write this here degree is 3. Again I repeat the thing that degree of every differential equation may not be defined. For example, first I write a differential equation, e to the power dy dx equal to x to the power 3. So this equation imply dy dx x plus 3. So in this equation, degree is 1, but in the differential equation e to the power dy dx equal to x plus y dy dx, here degree is not defined in this differential. This is also a differential equation, but in this equation we clearly say that order of this equation is 1, but here degree is not defined, because that here dy dx equal to log base e x plus y dy dx. So we cannot say the actual power of dy dx here. So degree of a differential equation may not always be defined. Clear? Now we come to linear and non-linear ordinary differential equation. Linear and non-linear. First, I am writing a form of differential equation of order n, such as P0 x. Here P0 x dny dxn plus Pn x dn minus 1 y dxn minus 1 plus plus Pn minus 1 x dy dx plus Pn x y equal to qx. Here P0, P1x, Pn minus 1x, Pnx and qx are functions of x, and mainly P0x not equal to 0. Actually this form. So I am telling again, a linear differential equation of order n in dependent variable y and independent variable x is an equation of this form, where P0 is not identically 0. This is linear equation, linear differential equation of order n. An ordinary differential equation is called non-linear if it is not linear. If it is not linear, then it is called non-linear. We provide some example of non-linear ordinary differential equation as dy dx whole square plus dy dx minus 6 equal to 0. This is an example of a non-linear differential equation. Actually, this equation is of order 1 and degree 2, and it is not in this form. Clear? This is nth order linear differential equation. This is first order non-linear differential equation. Again, we also give another example of non-linear differential equation as dy dx equal to sine x plus y plus cos x plus y. Now, we study equations of first order and first degree. We come to know equations first order and first degree. Equations of first order and first order and first degree. An ordinary differential equation of first order and first degree can be written as dy dx equal to f of x comma y. You have to observe that here the variable dependent variable y must be present in in the power of 1. That is, it may not be 2 or 3 or 4. It will always be y. In more symmetric form, this x plus n dy equal to 0. Here, m is a function of xy and n is a function of xy. হ্যালো
হ্যাঁ শাহানুস ভাই বলো।
শোনা যাচ্ছে তো?
হ্যালো,
হ্যাঁ শোনা যাচ্ছে।
আচ্ছা আচ্ছা here m is a function and n is a function. Theorem on first order and first degree, which is known as existence and uniqueness theorem. If the function f of xy be continuous, this function be continuous y0, continuing to the point x0 y0 of x and y, it is said to be exact differential equation. First I write example and then explain again. Here y dx plus x dy equal to 0. Here this is m, this is n, and we write this part as d of xy. So without multiplying any factor, this differential is expressed as this. So this equation y dx plus x dy equal to 0 is an exact differential equation. That is, if the differential equation m dx plus m dy is immediately, that is without multiplying by any factor, is expressible in the function of xy. Du here, du where u is a function of xy, then this equation is said to be exact differential equation. Now we come give another example of exact differential equation 2x2y dy plus 2y square x dx equal to 0. It is also exact because this part is expressible in the form d of x square y square. So this part is expressible without multiplying by any factor as this. So an example of a exact differential equation. Now we state an important theorem without proof by which we can check a differential equation is exact or not. The theorem is a necessary and sufficient condition that the equation m dx, that this equation m dx plus m dy equal to 0 be exact del y equals to del n del x. So a necessary and sufficient condition that this equation be exact is del m del y equal to del n del x. Now we check this condition is necessary and sufficient. Now we check by this theorem, we can check by this theorem an equation is exact or not. And now we give an example of such equation as x square minus y dx plus y square minus x dy equals to 0. Like here x square minus y is m and y square minus x is n. Now del m del y equals to minus 1 and del n del x equal to minus 1. So these two terms are equal. So this differential equation, these differential equation x square minus y dx plus y square minus x dy. Now we come to another important term for studying differential equation. Ordinary differential equation, in fact, is integrating factor. Integrating factor. Integrating factor. What is integrating factor? Integrating factor is a factor multiplying by which a non-exact equation can be made exact. Integrating factor is a factor, multiplying factor by which an equation can be made exact. Let us write an example to clarify this definition. Here we write x dy minus y dx equal to 0. This equation. Clearly, this equation is not exact. Clearly, this equation is not exact. But if we multiply this equation by 1 by x square, so it comes the form x dy minus y dx by x square equal to 0. Then this part is expressible in the form d of y by x equal to 0. So then this equation reduces to exact. So here 1 by x square is an integrating factor of this equation. Clear? Similarly, 1 by y square is also integrating factor of this equation. Similarly, 1 by xy is also an integrating factor of this equation. So, integrating factor of a differential equation is not unique. Clear? So, again I repeat the definition. A function a function of xy is said to be integrating factor of the equation mdx plus mdy equal to 0 if it is possible to obtain a function another function x of y such that multiplying by this term equal to d of some xy function. So if we take the equation as mdx plus ndy equal to 0 and mu x comma y as integrating factor, then multiplying this factor we can obtain another function as mu xy mdx plus ndy equal to d of x. So multiplying this factor we made this equation as exact. So here mu is integrating factor. It should be remembered that integrating factor is not unique. Now we come to the fact that there are several rules for finding integrating factor in a particular class size of equation. There are several rules. I am not going in brief, but there are so many rules. And before going to the study of the rule, we first have to study homogeneous equation. Homogeneous equation. First, we have to study homogeneous equation. Homogeneous equation. Actually, mdx plus ndy equal to 0. This is our equation. Here, m and n both are functions of x and y. This equation, that is mdx plus mdy equal to 0, is said to be homogeneous equation if both m and n are homogeneous function of the same degree. Homogeneous function of same degree. Say degree n. If mdx and ndy are homogeneous function in x and y of the same degree n, then the equation mdx plus ndy equal to 0 is said to be homogeneous differential equation of degree n. Now we give the definition of homogeneous function. Here m is said to be homogeneous if m can be expressed as m equal to x to the power n phi of y by x. Then if m is expressible in the form this, then m is said to be homogeneous function in x and y of degree n. Similarly, n is said to be homogeneous function of degree n if n is expressible in the form x to the power n phi of y by x. So the differential equation mdx and ndy is said to be homogeneous equation of degree n if m and n are both homogeneous function of degree n. Actually, I give definition, give an observation. Actually, this is our equation mdx plus mdy equal to 0. If this equation is homogeneous, then m is expressible in this form and n is expressible in this form. Then we can write this equation as dy dx equals to minus phi of y by x by psi of y by x. Is it clear, dear student? Is it clear?
Yes, sir.
Yes, sir.
Okay. This term, we say this as f of y by x. Say, if we put y, if we put y equal to vx, then if we put y equal to vx, then this equation can be written as x dv dx plus equal to x dv dx equals to f of v minus v, or dv by fv minus v equal to dx by x. We can be integrate this, so we can find out the solution of this equation here. So in the homogeneous form, in the homogeneous equation, we generally substitute y equal to vx, or it may be in reverse case x equal to vy. Now we come to another type of equation, that is equations solvable by separation of variables. Equations solvable by separation of variables. Here our first equation is mdx plus ndy equal to 0. Again I say m and n are both functions of x and y. If m is a function of x only, if m is a function of x only, say f1x, and n is a function of y only, say f2y, then this equation is said to have separated variables, that is f of x with dx and f2 of y with dy. I give example of these type equations. We write now first dy by 1 minus y square plus dx by root over of 1 minus x square equal to 0. Here we see that here dy and this is a function of y, and here dx and this is a function of x. So this is separated variables, and by integrating we can solve these type of differential equations. I give another example. X square plus 1 y square minus 1 dx plus xy dy equal to 0. We can easily separate the variables as dividing by this equation as y square minus 1 into y, or just simplifying this equation. So these equations are example of separated variables. Now I'm in the position to state the rules of finding integrating factor. Just I tell the rules as rule 1. If mdx plus ndy equal to 0 is homogeneous but not exact, and if mx plus ny not equal to 0, then 1 by mx plus ny is an integrating factor of mdx plus mdy equal to 0. The first condition is it should be homogeneous. If mdx plus ndy is homogeneous and not exact, and if mx plus ny not equals to 0, then 1 by 1 by mx plus ny is an integrating factor, uh, is an integrating factor of this equation. Next rule. I will not going in details with example because the time is very short. Another rule is if 1 by n del m del y minus del n del x is a function of x alone, say f of x, then e to the power integration fx dx is an integrating factor of this of the equation m dx plus n dy equal to 0. Rule 3 is also similar to rule 2 as if 1 by m del m del y minus del n del x is a function of y alone, say phi y, then e to the power integration e to the power minus integration phi y dy is an integrating factor of this equation, integrating factor of m dx plus n dy equal to 0. Now we go to the rule 4. Rule 4, this is an important rule. Rule 4, if the equation m dx plus n dy equal to 0 is of the form, if the equation is of the form, you have to remember this form actually is of the form y function of xy dx plus x f2 function of xy dy equal to 0, then 1 by mx minus ny is an integrating factor of m dx plus n dy equal to 0, provided mx minus ny not equal to 0. And also rule 5, this is quite laborious rule due to calculation, is rule 5. Rule 5, if the equation m dx plus n dy equal to 0 can be put in the form, x to the power a y to the power b my dx plus n x dy plus x to the power a prime y to the power b prime m prime y dx plus n prime x dy equal to 0, then the equation has an integrating factor x to the power h y to the power k, where a plus h plus 1 by m equal to b plus k plus 1 by n, and a prime plus h plus 1 by m prime equal to p prime plus k plus 1 by n prime. If we solve this, we have to find h and k, then h to the power and y, h to the power h and y to the power k will be the integrating factor of this equation. I also say that this rule is laborious due to calculation. Now I go to most general linear equation of first order linear equation. The general form of this equation is dy dx plus py equal to q. See this equation, and this is most general linear equation of first order. Most general linear equation of first order. Here P and Q, remember it, here P and Q are both functions of x alone or constant. Then this equation is said to be linear in y. Linear in y, and its integrating factor is e to the power integration p dx. And we also have known that by multiplying integrating factor, an equation can be made exact. So multiplying this integrating factor, here this is an integrating factor, multiplying this integrating factor, we can solve this type of equation as y e to the power integration p dx equal to integration q e to the power integration p dx plus c. This is the general solution of this equation. Hello, Ajit? Hello? Hello?
Sahanous bhai, bolo.
May I continue for 5 minutes?
Okay.
Hello. Now we come to another important equation known as Bernoulli's equation. First, see this form: dy dx plus py equal to q, where p and q are functions of x or constant. This is linear in y. Now we go to Bernoulli's equation. The form of this equation is dy dx plus py equals to q by to the power n. This form of equation is known as Bernoulli's equation. Bernoulli's equation due to the French mathematician Bernoulli. This Bernoulli's equation can be made linear equation by the substitution z equal to minus a. By this substitution, we can easily find out the integrating factor of linear equation, and then we can easily solve Bernoulli's equation. It is to be remembered that if an equation is difficult to solve in the form of linear in y, we can turn this equation into linear in x. This is like this: dx dy plus px equal to q. Then role of p and q will be changed. Here p and q are function of y only or constant, and this equation is said to be called linear in x, and sometimes it is easier to solve any problem by taking this linearity form. Okay, Ajit, hello.
Thank you, Sahanous bhai. Thank you, Sahanous bhai.
আরো প্রচুর বাদ থাকলো, কিছু করার নাই আর কি, ভেবেছিলাম বলবো, পারলাম না।
Okay, Sahanous bhai. Okay. Any questions, students?
Any
questions, students?
No, sir.
হ্যাঁ
স্যার আমার একটা কোশ্চেন আছে।
হ্যাঁ, বলো বলো।
স্যার আপনি তো বলেছেন mdx প্লাস mdy ইজ ইকুয়াল টু 0, স্যার এটা বলার সময় আপনি বলেছেন যে x0 y0 ইন্টেরিয়র। স্যার ইন্টেরিয়র মানে ইন্টেরিয়র বলেছেন কেন, এটা জানার জন্য?
যেটা ইন্টেরিয়র মানে একটা ডোমেন, তো ওই ডোমেনের ভিতরে থাকতে হবে, মানে x0 পয়েন্টটাকে ওই ডোমেনের মধ্যে থাকতে হবে, বাউন্ডারিতে বা আউটসাইডে থাকতে পারবে না।
আচ্ছা আচ্ছা ঠিক আছে, এটার জন্য
ঠিক আছে, ডোমেনের মধ্যে থাকবে। সাপোজ
ডোমেনের
ইন pictorial notation, this is domain. The x1 point, x0 point will be here, but not here or not here. Yeah.
তুমি কি সার্কুলার হবে?
No. I draw this. It may not be circular. It may be rectangular also. Okay. Any other question? Actually, this portion is most fundamental. The portion I have today covered is more fundamental. It is not advanced. It is more fundamental.
Any questions?
কোথাও যদি বুঝতে তোমাদের অসুবিধা হয় তোমরা বলো স্যারকে।
ওকে, শুভদীপ, আর বোধহয় ওদের কোশ্চেন নেই।
আচ্ছা ঠিক আছে।
ওকে, থ্যাংক ইউ শাহনাজ ভাই।
থ্যাঙ্কফুল।
Thank you, Ajit and his entire team. Thank you.
Okay.
May I leave?
স্যার ভবিষ্যতে কিন্তু আবার করতে চাইবো আপনাকে।
Of course, always. There are so many articles left today's class. I just only.
স্বাভাবিক স্যার, 1 ঘন্টার মধ্যে তো কতটুকু মানে বলা যায়।
Yes. Okay.
Okay, thank you again, Sahanous bhai.
Okay.
ওকে
I am leaving now.
ওকে 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 এই শুভদীপ দা, হ্যালো।
হ্যাঁ বলো। হ্যাঁ
আরে
বলো।
বলছিলাম আমার তো নেটওয়ার্কই কাজ করছিল না, 11টা বেজে গেল, কোনো রকমে ঢুকতে পারলাম।
স্যার সবার আমরারও নেটই
হ্যাঁ
কাজ করতেছিল না।
আমি তো কনফিউশনে পড়ে গেছি গা যে আমি ঢুকতে পারবনি।
আমি শুভদীপ স্যারের এসএমএস করছি স্যার,
স্যার
নেটওয়ার্ক কাজ করে না।
সবখানেই আমি ওয়াইফাই কানেক্ট হয়ে রয়েছি, আমারও নেট চলে না।
ঠিক আছে, তোরা বুঝছিস তো ভালো?
হ
আচ্ছা, এই শুভদীপ দা 28 তারিখ তো,
একেবারে বেসিক জিনিস শিখছে।
হ্যাঁ 28 তারিখ তো তোমার বুধবার।
হ্যাঁ হ্যাঁ হ্যাঁ, এটা ব্যাপারটা হলো আমরা একটা ডেট দিয়ে রেখেছি, কিন্তু যদি কোনো কারণে চেঞ্জ হয় এটা তো শুধু আমাদের স্টুডেন্টসের ব্যাপার।
হ্যাঁ
তো
হ্যাঁ
আমরা
হ্যাঁ,
ওই রিসোর্স পার্সনের সাথে কথা বলে সময়টা বা ডেটটা একটু চেঞ্জ করে স্টুডেন্টদের জানিয়ে দেবো।
না না, টাইমটা চেঞ্জ করে দেই, বিকালবেলা করে দেই বা সন্ধ্যার দিকে করে দেই।
এখন কিছু করছি না, এখন করি না, দেখি না
এখন না,
আসুক
ওর
সময়।
সাথে কথা বলে আমরা পরে ওদের জানিয়ে দেবো আর কি।
হ্যাঁ হ্যাঁ, সেই,
ওকে,
সেই।
তাহলে লিভ করি আর কি নাকি?
হ্যাঁ ঠিক আছে, যারা জয়েন করেছো সংখ্যা মোটামুটি 50 ছিল।
হ্যাঁ।
ঠিক আছে, তোমাদের ধন্যবাদ।